So remember, we're in our last unit. It's area and volume. So we're done with area. Now we need to tackle volume. So what I want you to do today is, normally I have like a full 50 minutes to explain it. Today we got a solid 30 minutes. So we're not going to finish. You'll probably leave a little confused. Okay, but I'm going to give you notes for tomorrow. Okay, for you. Do you have the papers, Marcel?
Marcel, you said you're going to...
Yes. Okay, so you might leave a little confused, but... Huh?
Do you have one there?
Yeah, just what I was going to do, though.
Okay.
You know. Okay, so tomorrow, here's the deal. You guys are going to have a sub, and so that means that your notes are going to be on my laptop, projected onto the screen. So I need you to come with a good attitude, because I won't be here for you to ask questions. Because Ashton gets his pins out tomorrow out of his hand. So I took the day off so that I can like throw up after blood gushes everywhere. Okay, so real quick geometry review. Okay, this part you should have. How do you find?
I don't remember.
Okay, well we're gonna review it. That's okay. How do you find the area of a triangle?
1/2 base times height.
Okay, good. Now, question. If your triangle is... We'll get a new paper because...
You can use mine, miss.
No, it's okay. I want you to just switch it around, miss. Okay, listen. No, how do you know?
Switch the letters.
No.
I already... It's like I can't start off on the wrong foot, you know? Okay. Girl, your life is a waste of paper. Okay. We'll try this again. What shape is the first shape?
Rectangle.
Okay, so draw a rectangle, boom. Okay, how do you find the area of a rectangle?
Base times height.
Okay, base times height, good. How do you find the area then of a square? Base squared. Now, why can I simplify that? Because if it's a square, the two sides have to match, so that if one of them's a height, really it's just the same as the base. Okay, for a triangle, how do you find? Yup. Now, I also want to point out to you, I know that you know this, but sometimes y'all forget this. It doesn't matter if it's a right triangle. Whatever this height is...
I honestly don't know why. Like, I always just break it apart.
I know. I noticed y'all did that on your thing. Yeah, don't break it apart. It's just one triangle. This is the height. Okay, but you don't have to, it doesn't have to be a right triangle for that formula to work. Even if it was this kind of triangle. I had to like try really hard to make it ugly. Okay, you would still multiply the base. I know, it is ugly. Okay, but you would still do 1/2 and then the length of the base multiplied by the height. It doesn't matter if it's an equilateral or a right triangle, or that would be called, do you remember, a scalene triangle? Do you remember that? Okay. How do you find the area of a semicircle? This one we should know.
Is it 1/2 pi r squared?
1/2 pi r squared. Good. And how do you find the area of an ellipse?
1/2 pi r squared.
Do you know what an ellipse is? It doesn't have an R. It's an oval, yeah? So when you have an ellipse, okay, I'll sketch it here. Instead of only having one radius measurement, you have two unique measurements for your radius. One of them is typically measured horizontally, and then the other radius, really it's not called that anymore, but would be measured vertically. So I'm going to call the vertical one J, and I'm going to call the horizontal one K. But remember, why can I not use R? Because there's two different R's, right? One of them is longer than the other if it's an oval. So the way that you would find the area of that would be pi, and then you would multiply J times K. Now, if I only want a semi-ellipse, I would also have to put a half in the front. Now, I want you to think about for a second the difference between the ellipse and the semicircle formula. For a circle, what do you know about these two measurements? They would be the Same. So that's why you can condense it into pi r squared and just kind of call it a day. Okay? All right, the last two things you have to know about are your special rights. Does anybody remember the ratios of a 45, 45, 90 triangle? It's 1x, 1x, and then root 2x. So yeah, basically. So whatever one side is, okay, the two legs are going to match, and then the third side is x times whatever that other side was times root 2. So for example, baby problem, okay, let's say that these two sides are 5. Then what's the other side? 5 root 2. Yeah? What if these sides were 7? Then that side would be 7 root 2. Good? Okay? All right, let's do a 30, 60, 90 now. Okay, so there's my 30, 60, 90. Now remember that the smallest angle, which is 30 degrees, will always be across from the shortest side. And then the bigger angle, 60, I'm going to put two little things in there, is going to go across from the longer side. Okay, so this would be my 60 degrees here. Now, I think Sean said it, it's 1, 2, and then root 3. So this is 1x. The longest side is always double that. And then the longer leg is x root 3. Okay? Yes, ma'am.
She left the calculator in here yesterday.
Who are you?
Testing her.
It's one of those right there, I think. I just don't know which one. Okay, so let's say little baby problem. You find it?
Mm-hmm.
Okay.
Thank you.
You're welcome. So let's say that this side, you're welcome, is 3. Then what would you say the long side is if it's 2x? 6. And then what would this side be? 3 root 3. Right? Okay, let's do one more just for fun. Okay, let's say this time that you know that this side is 10. Well, the hypotenuse is always double the shortest side. So how long would this side have to be? 5. And if this side is 5, then how long does this have to be? 5 root 3. Got it? Remember that? Okay, good. All right, we'll do more with that in a bit. So here is the deal for today. Go up to the very top now that we've done our little geometry review. You are going to be finding the volume of solids, and as of today, I'm not going to really try very hard to explain to you what the solids look like. We'll go over that tomorrow some. But the way that you do it is volume is the integral of area. Volume is the integral of area from A to B. So if you keep reading here, it says that A of x stands for the area of the cross section perpendicular to the x-axis. Now, when I say cross section, it's going to be one of these shapes. So if I were to take a loaf of bread and I were to slice it, the cross section would be the shape that you would see if you opened it up. So, fun game. Let's say that I sliced my calculator. What would it look like? Kind of like a rectangle, right? Okay, what if I were to take my mouse and slice it? What would it kind of look like? Maybe like an oval but kind of flat on the bottom, right? What if I were to take, this binder and slice it? What would it be? A triangle. What if I were to slice it though this way? It would be a rectangle. So it matters which way you slice the shape. So today, you are only slicing perpendicular to the x-axis. Okay? So here are the steps, then we're going to work through an example. You're going to set up the region of the base. Okay, this you already know how to do. You're going to set up the region of the base, and then I want you to shade it. If you are taking your cross sections perpendicular to the x-axis, then your integral will be dx, which is the kind that you're already used to. Then you're going to write the formula for the base, which will be top minus bottom. And then your base is going to be written as an expression of x. We'll talk about that in a second. Okay, then you're going to write your area function. You're going to set up your integral, and then you're going to evaluate, which is almost always going to be with the calculator unless they really carefully work it out to where you can do it by hand. So, just some general things before we keep going. Let's say that your region is like this. We'll say that this is f of x. This is g of x. Okay, a lot of the setup for this is the exact same for area. If this is my region, what would I need to find before I can do anything? Okay, the intersections, right? How do you find intersections? You set the equations equal to each other. So you would need to know that first. So after you shade and you find your intersections, you're going to draw in your base, which is perpendicular to the x-axis. That means that it runs this way. So can you see why it would be top minus bottom? Okay, if I'm running up and down. Okay, that's what your top minus bottom is going to be. So in this case, my base would be f of x minus g of x. Now, what if g of x was bigger? Then you'd flip it around. Okay? It doesn't matter where you put the line. F would always be on top, G would always be on bottom. Okay, now after that I'm going to write my A of x, but that's going to depend on the shape that's given. And remember that they have a couple different options. We just filled your whole first page with all the different shapes. Rectangles, triangles, squares, blah, blah, blah. Okay? And then your volume is going to be the integral of the area equation from a to b dx. So when you're ready, turn the page. We're going to work through this first one. Okay? Okay, so set up your region. Pretend like this is normal area. The first part of this is all repeat. You know how to do it. Okay, we want x plus 1. How is that shaped? Yeah, up 1, and then it goes uphill or downhill. Okay, there's your graph. That's y equals x plus 1. Okay, then my second graph is y equals x squared minus 1, which is going to be shifted down 1. So I'm going to go down 1 right here, and then I'm going to make my graph open up. Okay, shade your region that's enclosed by that. It would be this region right here. And then what are we going to need to stop and find before we keep going, we said? The intersections. Very good. So I need to know where these guys cross, here and here. And to find those points, I'm going to set them equal to each other just like before. So I'm going to let x squared minus 1 equal x plus 1. Okay, and then I'm going to label this intersection since it's your notes. You don't have to do that on the AP test or anything, but that would be, maybe for your notes, that would be good. Okay, we're going to move the x across. And then if I have a minus 1 and a plus 1, when the plus 1 moves over, now it's going to be a what? Negative 2. Good. And so if I need numbers that times to minus 2 and add to negative 1, I'm going to pick x minus 2 and x plus 1. Which means, where do they intersect? Positive 2 and negative 1. Very good. So this one here is going to be negative 1. This one here is going to be 2. Okay, the next thing that I want you to do is I want you to draw in your base. Now, as I said earlier, the only bases we're going to look at today will be perpendicular to the x-axis, which means that when I draw them, they're going to be running top minus bottom. Okay? So draw that in for me. That's going to be your base. And your base is going to equal the top function that it's touching minus the bottom function that it's touching. So the top of my region is which equation? X plus 1. And the bottom of my region is x squared minus 1. Now, you're going to have to rewrite that expression several times. So to make it easier, I'm going to simplify it to make it look nicer. So I'm going to let the negative x squared come first, then the plus x, and then what is plus 1 minus negative 1? Plus 2. Okay, and I'm going to simplify that only because I want to, not because you have to. That's up to you if you want to do it or not. Okay, so this is my base. Okay, now, on the AP test, they're only going to give you one shape at a time. We're practicing with 4 just so that you'll see lots of variations. So the first one, they want a square. How do you pretend none of this happened? How do you find the area of a square? But the base and the height, they're going to match each other, so how would you find the area? Base squared. What's the base? Boom, that. So area equals negative x squared plus x plus 2 squared. Now, what is the difference from line 1 to line 2? This is the generic area formula. This is the area in terms of what letter? X. Why do I need it in terms of x? Because volume is the integral of area. So I'm going to say volume is the integral of this. And if you look back on the front, remember we put volume equals the integral of a of x. So this is my a of x. Now, what boundaries would I pick? The same boundaries you would have picked for area. What are my endpoints on my graph? Negative 1 to 2. And then from there, like I said, usually on the AP test, they'd give you a calculator. You just type that in. Okay? So let's go to part B. This time we want a rectangle with a height of 5. We're going to start with the generic area formula. How do you find the area of a rectangle usually? Base times height. But now what's the height? Height is 5. So I'm going to plug that in here. Okay, well then really, it's going to be base times 5 or 5b. Now, the order there doesn't matter. They're the same. B times 5, 5b, same thing. Okay, so how will I turn that into an a of x? I'll take my substitute here, and I'll replace it where the b is. So now a of x is going to be 5 times my base, which is negative x squared plus x plus 2. And then if this is area, how do I turn it into volume? I integrate it. So volume will be the integral of 5 negative x squared plus x plus 2 dx. And then what are my endpoints? Negative 1 to 2. Very good. Now, the other thing I do want to point out to you is that since 5 is just like a normal constant, do you remember that it could also be moved out here? Okay, it doesn't matter where you put it. It's easier usually if you put it in the front, but you should know it can go in either place. It doesn't matter. Okay, so go down to the next one, part C. I want an isosceles. Yes, ma'am. You could distribute. Yes, ma'am. Okay, next one, I want an isosceles right triangle. What does isosceles mean? Two sides match. 2 equal sides. Okay, now look what it says. I want the leg to be in region R. So that means that this is going to be base down. Those have to match each other because it's isosceles. Okay? So, area for a triangle is 1/2 base times height. But because my triangle is isosceles, what do I know about the base and the height? They have to what? They have to be the same. So instead of 1/2 base times height, I'm going to put 1/2 base squared. Okay, and why am I allowed to do that? Well, if I say isosceles, base and height are the same, so I'm just squaring it. Yes, sir? Because it says that the base is going to be in region R, and region R is the bottom. And when we visualize these with an applet on the computer, it'll make more sense why that is. But basically think about region R is the base of the shape. So if the base is in region R, that means that's this bottom part right here. Okay? So from here, I want to turn that into an a of x. and then I want to put a of x into an integral. So a of x would be 1/2. My base is negative x squared plus x plus 2. And then I need to keep a squared on it because remember that's representing both my base and my height. Okay, well if that's a of x, then what's volume? I put an integral on it. Now this time I'm going to put the 1/2 in the front, and I'm going to keep the negative x squared plus x plus 2 on the inside. Negative 1 to 2. Okay? Anybody confused yet so far? Or doing okay? Okay. I'm going to skip equilateral and just go to the next one just so that we can look at several different examples. So we need to go back to this, but I'll put it in the video for tomorrow. So turn the page, next base. Actually, go to this one. I want to do the last one. This is a better example. Okay, so I want negative x squared plus 9 and x squared minus 3. What are my shapes going to be? This is the last one in your packet. How's that one shaped? Downwards, and it starts where? At 9. Okay, then my other one is x squared minus 3, so that's going to start at negative 3 and it'll open up. So here. Okay, shade your region. Remember, we want to stay between those two graphs, so I'm shading this part right here. The 2 would make it narrower. So if you drew it maybe a little more accurately, that 2 should be narrower than the x squared. Okay, then from there I need to find where those intersect with each other, which means I'm setting them equal. So I'm going to let negative 2x squared plus 9 equal x squared minus 3. Okay, well I'm going to add my 2x squared across. What is x squared plus 2x squared? 3x squared, good. Okay, minus 3. What would I do next? I'm going to get rid of the minus 3 by adding 3. What's 9 plus 3? That'd be 12, right? Then divide by 3 on both sides. That means that x squared is 4, which means that x is plus or minus 2. Good with that? So this is x equals negative 2. This is x equals positive 2. Okay, so I shaded my region. I found my intersections. Next, you're going to draw the base. Remember, all your bases today are perpendicular to the x-axis. So if I want to be perpendicular to x, you draw in your base right there, and you do the top function minus the bottom function. No matter what base they give you, or no matter what shape they give you, the base will be the same. My top function was negative 2x squared plus 9. My bottom function was x squared minus 3. And then remember, it's up to you. If you want to condense that to make it more simple, that's fine. If you don't want to, that's fine too. Okay, but I'm going to here. So my base is going to be negative 3x squared. And then 9 minus negative 3 is really a plus 12. That's my base. No matter what shape they pick, that's my base. Okay, first one I want is a square. How do you find the area of a square? Base squared. And how do I get from area to volume? I turn my area function into an integral. So a of x would be negative 3x squared plus 12 squared. And then my volume would be an integral around that. What would my endpoints be? What are the endpoints of my region? Negative 2 to 2. Now, from here on out, I'm going to skip this step. Okay, just because it's easy and you're not going to not understand if I don't put that, right? So look at the next one. I want a rectangle. What's the area of a rectangle? Base times height, but then what does it tell me the height is? 2x plus 1. All you do is say, okay, well then it's base times 2x plus 1. Don't overthink it. It's base times height. They gave you a height that they want you to use. And then how do I go from area to volume? I take my area, I put it in an integral. So volume would equal the integral from -2 to 2. And then my base is this junk right here, multiplied by my height, which is 2x plus 1 dx. Make sense? And then you would plug it into the calculator. Yes, ma'am. So this is the base that I found. This is the height that they gave me. Okay? 42. Okay, last one I want to do is D. Okay, how do you find the area of a triangle? 1/2 base times height. And then what does it tell me about the height? The height is modeled by what? 3x. So then I'm going to rewrite my equation to be 1/2 base times 3x. And then remember, how do you get from area to volume? You turn it into an integral. So it'd be volume equals integral 1/2. My base is -3x squared plus 12. And then my height is 3x dx. You could put the 1/2 in the front. You could also take the 3 out as well if you wanted to and make it a 3/2 in the front and then the integral. Well, so I'd have to leave the x on the inside, so it'd look like this if you were to do that. Sure. Okay? Yes. Is that good or more?
Can you fill this out for me real quick for scholarship?
Sure.
And then just give it to me ASAP. If you can't finish by the end of class, I'll
Okay.